All right. We are live. So let's go ahead and close this, save this up. Almost 50% through the course. Woohoo. Let's go ahead and go back to this one. We'll
Okay,
refresh.
we got to iteration statements. If you have done programming before, you know that pretty much every programming language has a set of iteration statements which are used for repeatedly executing a sequence of statements. In C#, we have 4 iteration statements: for each, while, and do while. So let's examine the syntax for each of these iteration statements. For loops have 3 parts. Here's the first part, semicolon, second part, semicolon, and the third part. The first part is what we call the initialization clause, and that's where we create a counter for controlling the number of times the loop will be executed. So here I have created a counter called I and set it to 0. You're free to use any names for your counter variables, but I is a common convention. The second part is what we call the condition clause. So the for loop here will be executed as long as this condition is valid. And the third part is what we call the iteration clause. And here we typically increment or decrement the counter variable. So here, because I set I to 0, I would increment I in every iteration until it reaches 10. And inside the body of the for block, we have a sequence of statements that will execute repeatedly. For each is used to iterate over elements of an enumerable object. What do I mean by enumerable? In simple words, that means anything that has some kind of list or array nature. So far, you have learned about arrays and strings. A string, as you know, is a sequence of characters. So a string is enumerable. The array type is also enumerable. So anything that has some kind of list nature is enumerable. And we can use for each to iterate over their elements. We can definitely do the same thing with a for loop, but doing that with for each is easier and cleaner. In terms of syntax, here is what a for each block looks like. We have a local or temporary variable, in this case I call it number, and here we have the in keyword, and here is the list or object that we are iterating. So assuming that numbers is an array of integers, in every iteration, number will hold the value in the current element of the array. In C#, we also have while loops. In terms of syntax, a while loop includes a condition here, in parentheses. As long as this condition is valid, the loop will execute. Typically, we have a counter that we initialize before the while loop is executed, and at the end of the while loop, we increment it. So as you see, it's kind of similar to for loop, but it has a different syntax. Whether you use for or while loop, it's up to you. It's kind of personal preference. And finally, we have do while loops. Do while is slightly different from while loop. With do while loop, the loop is executed at least once because the condition is evaluated at the end of the loop. So here we have do, a block of statements that will execute. We have our counter, which we increment or decrement, and eventually is the condition. Now, you don't always need a counter with while and do while loops. You can use any condition. In the slides here, I used a counter called I to demonstrate that the same thing can be implemented with a for, with a while, or with a do while loop. And finally, before we start coding, let me show you 2 more statements here. We have break and continue. So in any loops, we can use break to jump out of the loop or continue to jump to the next iteration. Now let's start coding and see what all of this means in action.
All right.
Okay, imagine we want to...
Okay, let's see. Let's go ahead and get our canvas set up. There we go. I feel
display
good
the
today.
list of even numbers from 1 to 10. So we need the loop to go over the list of numbers between 1 to 10 And for each number, we need to check the remainder of its division by 2. And if it's 0, that means it's an even number. So let's start with a for loop. So with this loop, we set I to 1. And as long as I is less than or equal to 10, in each iteration, we increment I by 1. Now we need to check the remainder of division of I by 2. So if that's 0, we want to display I on the console. Just that. Let's run the application.
Alrighty. 2. Alright, now we're ready. Oh, oops. This is supposed to be 1. 1. There. There we go. 2, 4, 6, 8, 10. Should be what he gets. Yeah.
So we got 2, 4, 6, 8, and 10. Now what if we want to reverse this order? Let's try this program again. So this time, I'm going to create another for loop, but instead of starting from 1, I start from 10.
How come he doesn't just take this?
And I change the condition to as long as I is greater than or equal to 1, then I minus minus, which means decrement I by 1. Now we're going to have the same condition. Console the right line, I. So let's run the application again.
Oh.
Okay, now you see in the second part, we start from 10, and then we have 8, 6, 4, and 2.
Right now. Alright, he's going to the next one, but okay. So where am I messing up? Oh, right here. String. Damn it, I'm gonna have to go back. See what his stuff looked like. Maybe my shortcut didn't work.
And then I.
So he's got 4, 4. Bar I equals 1. Bar I equals 10 foot. What am I doing wrong? Static void 4, 4. Maybe it's just if it's a oh, that was it. Okay.
So let's run the application again.
Is that what you got? When is this different? It's like 2, 4, 6, 8, 10, 10, 8, 6, 4, 2. Greater than or equal to I minus minus. Oh. That's what he, okay. There we go. Cool, we did it. We did basic programming. Alright, let's go to the next one.
Okay, now let's take a look at the for each loop. But before we start with that, let me write a simple program with for loop, and then I'm going to show you how for each makes that program.
Okay, so we're all the way back to this point. Okay.
Cleaner and easier to understand. So let's imagine we have a string called name. So var name equals, we set it to John Smith. So a string, as you know, is a sequence of characters. It's an enumerable object. It's like a list. So we can iterate over that. So now I want to iterate over this string, and I want to display each character on a new line. So I start with a for loop. So let's see what's happening here. This time I'm setting my counter variable.
I was trying to type, catch up, or stay caught up with it, but I messed it up. It's for var I equals 0, boop, I greater than name dot link to I plus plus.
To 0, because the index of the first character in a string is 0.
I can't see. Can I pull this out? I can't. Dang it. You guys probably hear the birdies.
And I'm going to increment I one at a time.
Annoying birds. So annoying.
As long as I is less than the length of name. So as you see here, each string, like name, has a property called length, which returns the length of that string. Okay, now let's display each character on a new line. Name of I. Pretty simple, right? Let's run the application. So that's the output I was talking about. Now let's see how we can rewrite the same code using a for each loop. So with for each, I don't have to worry about a counter variable like I. I don't have to set it to an.
Okay, I got to the point where he was, so you guys can see it. It types it out that way. I don't want that. So now I did. Wait. So for. Yeah. Each our character in. Oh wait.
Initial value like 0. I don't have to compare it against some other value like name.length, and I don't have to increment it. So instead, we have a variable here called character, which in each step of the iteration holds one character of the string. Also interestingly, note that in the console on the right line, we can simply display character instead of accessing the character at the given index in the name variable. Okay, now let me comment out our for loop. So with Control K and Control C, now let's run the application. We got the exact same output.
Wait a minute. I'll just delete this. Okay. Yeah, we did get the same output. What are we doing wrong?
So whenever we have an enumerable object, like a string or an array or any kind of list, it's much easier to iterate over them using a for each. Let's change this example and iterate over an array. So I'm going to clean up everything here. Now I'm going to define an array of numbers, var numbers, and I'm going to use object initialization syntax to initialize that array with some numbers. So that looks like this. 1, 2, 3, 4. So with arrays, as you see, we have to instantiate them using the new operator. Okay, now let's iterate over this array. For each var number in numbers, console.writeLine number. Let's run the application.
Okay. So this is just like kind of muscle memory mostly. Var number in numbers, which is always good. 1, 2, 3, 4.
So as you see, for each is an easier way to iterate over a list.
Cool.
Okay, earlier we wrote this simple program.
Oh, I'll let him explain this one since he went back to the other program that we wrote. This one's 7 minutes long.
To display the list of even numbers between 1 to 10 using a for loop. And I told you during the slides that you can write the same code with for, while, or do while loop. So now I'm going to write the same program using a while loop. Okay. Before we get started, I want to comment out this code. So
never mind, I can do this. I want to do it anyways. He's pretty much deleting that code.
Okay, first let's declare a counter variable. So I
is
0
equals 0.
While I is less than or equal to 10. Now our condition. We display I on the console if it's an even number. And here we need to increment I by 1. So this is the exact same code, but written using a while loop. Now in this case, I prefer to use a for loop for this scenario, because typically we use the for loop when we know the number of times we would like to do an iteration. So it's cleaner to declare that counter variable like I when we are declaring the for block, as opposed to outside the while loop as we have here. Okay, now you might be wondering, when do we use the while loop? Well, there is no hard and fast rule, but typically it's better to use a while loop when you don't know ahead of time how many times you're going to do an iteration. Let me show you an example here. So first, let me clean up this code. We want to write.
So he's cleaning it up again. All right. Like I said, it's just muscle memory. Gotta keep practicing. All right.
A simple echo program. In this program, we're going to display a message on the console asking the user to type their name.
Oh, this is
if the user types their name, the console is going to repeat or echo that name. But if the user simply presses enter without typing a name, the program is going to terminate. So in this case, we don't know ahead of time how many times the user is going to use the program. How many times are we going to echo? In that case, it's better to use a while loop. So how do we do that? So in this case, we're not going to have a counter variable. So instead, what I'm going to do, I'm declaring a while, and in the condition, I'm just going to use true, which means this loop is going to execute forever. Let me display a simple message on the console. So console.write. This time I'm going to use the write method instead of write line. The difference is the cursor is going to be on the same line. We're not going to have a line break. So type your name. Let me run this program and see what happens. So you see this program is executing forever because that while loop is not terminating. And the program keeps displaying type your name.
Oh, it's going
So
and going.
So at this point, we need to read something from the console. So we use console.readLine method. And this method, take a look at its signature. So I remove the parentheses. I open it again. Look at the tooltip. This method returns a string. So we can store the result in a string, call it input. Now, if the user simply presses enter and do not type a name, that input is going to be an empty string. And if that's the case, it's the time to jump out of the loop. So, to check if a string is empty, we often use string.isNull or white space method. This method expects a string and returns a Boolean value. So if input is null or white space, then this condition is true. And then at this point, we're going to break. And with break, we jump out of a loop. Otherwise, if that does not happen, we want to echo the name. So console.writeLine echo. And now we're going to append the input here. Let's run this application. So type your name, Mosh, echo.
Wait, I wasn't ready to go back. Oh, so it's this echo. That's no. So enter and close it. Load it. Why is it saying at to go?
Let's run this application. So type your name, Mosh, echo Mosh. Note that the program continues execution. So this time I type John. And it echoes John. Now this time I'm going to press enter. And the program terminated. One of the questions beginners ask me is, how does this press any key to continue appear here? I didn't write any code for that. When you run your application using Control and F5, by default, when the application terminates, the console displays that message for you. Okay, now I'm going to change this program a little bit so we can learn about the continue keyword. So what I'm going to do here is I'm going to apply a not operator here. So if the input is not null or white space, in that case, we want to echo it, right? So let's not worry about this break. I'm going to move this console.writeLine here. Now I'm going to put that break here. So what do you think is going to happen now?
We then put this, this, this.
When we run the application, first we get this message, type your name. We type a name. Of course, it's not null or white space. We're going to get an echo, but then we get to this statement, and that causes the loop to terminate.
So it's going to ask you once, and then that's it. So, loading. That's it. Yep.
So this program is going to execute only once. How can we change this so it can behave like before? That's when we use the continue keyword. So I'm going to put the continue here, and let me explain what happens. So at this point, after we echo the name, when the program sees this continue, instead of continuing here, it's going to continue to the beginning of the loop. So we get back here, and the condition is true. Here. So the loop continues to execute. Let's run the program. Type your name, Mosh. The loop is continuing. Type your name, John. Now this time just press enter and the loop terminates. So as you saw, we can write the same program in different ways. Sometimes you may apply a not operator, and because of that you may have to use the break or continue. Which one is right, which one is wrong? There is really no right or wrong. You need to do your own. In this video, I'm going to show you a useful class to know in .NET Framework, which is called random.
Randoms. All right. Close this stuff. Oops.
We use this class to generate random numbers. So first we create an instance of the random class. This class has a few useful methods. Next, which returns a random integer. Next bytes, which takes a byte array and fills it with some random numbers. So you can create a byte array of any size, pass it to this method, and this method will fill that byte array with some random numbers. And next double, which returns a random double between 0 and 1. Let's take a look at the next method. This method has 3 overloads, as you see on the screen. The first one takes no parameters, and it simply returns a non-negative random number. So let's create a for loop and generate a few random numbers and display them on the console. Okay, let's run the application. So you see some random numbers.
Let's run the application. Type that way too fast. 10 boop. I plus console. And then he took this out. Bam.
Application. So you see some random numbers here. Now, there is something interesting we can do with the next method. Let's take a look at this method again. The second overload takes a maximum value, and the third overload takes a min and max value. This is very useful when we want to limit the range of random numbers. So if you want to create random numbers between 1 and 10, we simply supply them here. Let's run the application again. So now we have random numbers between 1 and 10. We can use this technique to even generate random characters, like random passwords. Each character internally is represented using a number.
That's kind of cool.
Because computers
It's a pretty good, like, basic program that's useful in a lot of other things.
don't understand characters and letters. They understand numbers. Let me show you what I mean by that. So I temporarily comment this out. And all I want to do is display character A on the console, but I want to cast it to an integer. We got 97. So 97 is the standard number to represent a lowercase a in a computer. This was first introduced as ASCII, which stands for American Standard Code for International Interchange. Let's take a look at this website, ASCII-code.com. So in this table, you can see the letters like, let me show you here, like plus, all these numbers are alphabets A, uppercase A to Z, lowercase. See, all these characters have a number represented in decimal format, which is here, and they also have a binary representation. This is eventually what a computer understands. Now, if you look at 97, you see a lowercase a. And let's take a look at the Z. So Z is 122. So what this means is if we generate a random number between 97 and 122, and then cast it to a character, we'll get a random character. And we can repeat this a few times and generate a random string, like a password. Let's give it a try. So let's bring this back in. What I want to change here is limit the range to 97 and 122. Now, if we run this application, we're going to get a number coming from the next method. So we need to cast it to a character. And I'm going to change right line to right because I don't want each character to be on a new line. Let's run the application. This press any key to continue message is messing up with us. So let me add a console.writeLine here so you can see more clearly. There you go. So here's a random string. Now, a tiny problem with this code is if someone look at this code, they have no idea what is 97 and 122. So let me show you a more expressive way to write the same code. What we can do is replace that with 0 and 26 because we have 26 characters in the English alphabet. Now, we get a number between 0 and 26. If we add that number to character A, what do you think is going to happen? Well, this is a character and internally is represented as a number. And when we add this character to a number, the result is going to be a number. Then we cast it to a character, so eventually we get the same result, a random character. Now, in the real world, we don't want to create a random string and display it on the console. Most likely, we would like to store it in a string. But there is a tiny problem here. In the last section, I told you that strings are immutable, which means once you create them, you cannot change them. Of course, there are methods that you can apply on a string and you get an updated value. But in every case, the original string is not affected. You always get a new string. So in C#, we cannot create a string and set its individual characters using a random character. But what we can do instead is to store this result in an array and then create our string based on that array. Let me show you how it works. So first, I declare a character array. Let's call it buffer. And because we are generating 10 random characters here, I'm going to set the size of this array to 10. And of course, we can use var here. As you see, the green highlight is indicating that. The code is cleaner. Now, Instead of displaying each character on the console, we can simply store it in the buffer. So let's get rid of this console.write and store it in the buffer. So I'm using the loop counter variable, to access an element in the buffer array. Now, the last step is to create a string based on that character array. Now, most of the time, we create a string like this. So we use a string literal. But there is a less common way to create a string in C#. It's not something that you use every day, but it's good to know that as something in your toolbox. So we use the new operator. If you remember from last section, the string keyword maps to a string class in the .NET framework. And you know that with classes, you can create an instance of them using the new operator. So we can do new string. And look, here in the constructor of a string, we have a few overloads. The last one, as you see here, takes a character array. So if we pass our buffer here, we will get a string based on that character array. Now we can display this password, which is a string, on the console. Look, we got the same result.
Whoa.
One last thing I would like to add here to improve the quality of this tiny little code, and that is, I don't like these magic numbers here, 10 here and 10 here. The problem with this is, if tomorrow we decide to change the length of our random password, we have to come here and change this 10 to 8, and we have to remember to do this here as well. So a better way is to declare a constant like password length, set it to 10. We can use that to create our array, and of course use it in the for loop. The code is more expressive and more reliable. So that's all you need to know about random class. I hope you enjoyed this lecture, and thank you for watching.
Cool. I think that's it for this. Yeah, we're on the quiz now. Let's do the quiz. What is the correct syntax to check if a number is not 0? Not equal 0, right? Yeah. Which correct answer correctly demonstrates the use of for loop to get numbers 1 to 10. For var number equals 1, number greater than number plus plus, number less than 10 plus plus. I think it's this one actually. Yeah. Var cities equals new string of Warren Sydney. Syntax to iterate over the cities using for each block. Oh, I don't know this one. Oh, I was close then. I thought it was that one at first. How many times will this loop execute? Var equals 0 while numbers is less than 5, numbers plus equal to. So, I mean, it would repeat 3 times, but it's not adding more. So the first time the number is 0, so it's less than 5, then it'll be incrementally by 2, so it's still less than 5. Next will be 4. Okay, cool. All right, so we got some exercises. I think I'm gonna save these for the end of the course. We'll do like a little special hour on those.
So in this section, you learned about conditional and iteration statements in C#. I hope you spent some time doing your exercises. If you have been programming for a while, don't say, no Moshe, I have done this a million times before, it's too easy for me. Trust me, these exercises help you become a better programmer. And that's what we're going to do from this section onwards. So in every section, again, you're going to see a number of programming exercises, and they gradually get more challenging. So do your exercises, and I will see you in the next section.
Yeah, guys, do your exercise. Okay, so, stop. Pause. So let's see here. This is where we're at. We got section 6, 7, 8, 9, 10. Now we're done. So this one's 30 minutes long, but it's got exercises. This one is short, no exercises. This one's got a few exercises, and that one's a little longer. This one's short. This one's kind of short. Let's see. I'm trying to decide if I want to just end it today, and we could start. You know what? Let's try some of these exercises. That's what we'll do. We'll work on this one. Okay? That's how we'll finish the day. Oh, I guess I could just go to the exercise. All right, let's figure this out. Close this. Okay, so write a program and ask the user to enter a number. The number should be between 1 to 10. If the user enters a valid number, display valid on the console. Otherwise, display invalid. This logic is used a lot in applications where values entered input boxes need to be valid. So, man, my brain just goes poopy when I start thinking about like what do I have to start with. If we'll just figure it out. Let's see. Number. No. Gosh, I'm so freaking lost. That's why it's so hard for me to learn programming. Just like I need a reference or something. I just need to pay attention more. Frick. Okay, let's see. No. Let's see. So I guess 4 var number. No. Var number equals see, and then it would be um, this stuff's stupid. That's why you practice it though. So let's see. I wonder if I could just do or I'm trying to think. You know, we're gonna do this next week. I'm gonna practice a little bit. Alrighty. Thanks for stopping by, everybody. I will catch you